Hello everyone. I'm putting this video together to give you a little bit of a lead on the last question on the chapter 7 homework on probabilities. This particular question, as you can see, is on joint probabilities, and you've worked on different parts of this question before, on how to calculate joint probabilities or marginal probabilities, as the question may have been. But this particular question is asking, use the special multiplication rule to determine whether events P sub 1 and C sub 2 are independent. So you have to use the the formula, or the formula behind independent probabilities in order to work this problem out. Now, if you recall from the lecture, we said that to determine whether two events are independent or not, we use this formula. And let me just pull out the pen here. It goes like this. It's probability of A given B. So let's say we want to first know whether A and B are independent. A and B are independent, all right? So if that's what we are trying to determine, then the formula is probability of A given B, which is the conditional probability formula, is equal to the probability of A. All right. So this is the formula that for independent probabilities. All right, to determine if two events are independent or not. So if we calculate probability of A given B and also calculate probability of A, if they are equal, then we can conclude that the events are independent. However, probability of A given B, the conditional probability, has its own formula, which is probability of A and B over the probability of the given condition probability of B, correct? Now, and then on the other side, we have probability of A. So on the left-hand side, we have the formula for the conditional probability, which is probability of A and B over probability of B. And on the other side, we have the probability of A on the other side of the equation. Now, if we transform this formula, that means if we get rid of this denominator on the left-hand side, what will we get? We get probability of A and B, right, equals probability of A multiplied by probability of B. All right, so if you multiply, all right, just like you transform equations, all right, if you want to get rid of the denominator, what do? You multiply both sides of the equation by probability of B, right? Probability of B. And this side cancels out, the probability of B in the denominator divides on the left hand side, and we are left with probability of A and B equals probability of A times B, which is called the special multiplication rule. This is the special multiplication rule. Now, the question here says we have to determine if if P1 and C2 are independent using the special multiplication rule. So probability of A and B equals probability of A times probability of B. This needs to be calculated. All right. So in our case, it's P1 and C2. So it would be probability of P1 and C2, the joint probability. Is it equal to the probability of P1 multiplied by the probability of C2? All right, so probability of P1 and C2, that's the joint. Again, the joint probabilities are inside this box. this bold rectangular box. So P1 and C2 would be this one, right? So on this one side, we will have 0.084. Now I leave you to do the rest of it. I'm not going to give you the entire answer, but what you have to do is find probability of P1, multiply it by probability of C2, all right? These are not joint probabilities, these are marginal probabilities. So you have to find out from here what the probability of P1 is, what the probability of C2 is, multiply them and compare it and see whether the two sides are equal or not. If they are equal, you're going to say it's independent. If they are not equal, you're going to say they are not independent. All right, so that's how you're going to go about solving this particular problem. Okay.